Hello everybody, this is Peter Wilson, and this is a video lecture to accompany section 13.2, which is on the very interesting topic of asteroids and planetary defense. And this is for Astronomy 201 or Astronomy 1101 at Medicine Hat College. Although most asteroids are in the main asteroid belt, several thousand are in orbits that come close to that of Earth. In 2013, a small asteroid, probably too small to be called an asteroid, exploded in the sky near the Russian city of Chelyabinsk. The energy of the explosion was about 500 kilotons, or 30 times that of the Hiroshima and Nagasaki weapons. This was not the first powerful airburst of an exploding asteroid-type object over Russia. In 1908, a 40-meter object exploded over the forest near the Tunguska River in Siberia. The energy of the explosion was 5 megatons. Hundreds of square kilometers of forest was flattened. At the time, the cause of the explosion was a complete mystery. And so these two pictures, picture A shows a Chelyabinsk meteor burning up in the atmosphere. We shouldn't call it a meteor, should call it a meteorite. And picture B shows some of the trees that were knocked over in the Tunguska blast. So in 1998, NASA began the SpaceGuard survey with the goal of identifying 90% of the Earth-approaching asteroids larger than 1 kilometer. 1 kilometer was assessed as the minimum size of an asteroid large enough to cause global damage. This goal was accomplished in 2012 when nearly 1,000 of these objects had been found, along with more than 10,000 smaller asteroids. It's important to point out that none of the known Earth-approaching asteroids is on a collision course with Earth. Throughout the recorded history of mankind, Earth has never been hit with a major impact, although the Earth is dotted with the remnants of major impact craters, showing that such impacts do occur. Complacency might be misplaced, however. First of all, we haven't yet identified all of the Earth-crossing objects, and secondly, every close passage of an asteroid is unique. Beyond that, the orbit of an asteroid might be affected by a near passage of another object, so that an asteroid on a trajectory to miss all of the other planets may be deflected in such a way that its trajectory does intersect with ours. Thirdly, the population of Earth-crossing asteroids is constantly being augmented by new arrivals due to a resonance phenomena within the asteroid belt with Jupiter. And what happens is Jupiter is continuously kicking asteroids out of the asteroid belt, and they can end up in an Earth-crossing orbit. The really disturbing news is there are estimated to be about 1 million near-Earth asteroids big enough to destroy a city. For smaller objects, we will only have a few seconds of warning in advance of an impact, as was the case with the Chelyabinsk explosion. Clearly, there's some merit to the idea of tracking as many of these objects as possible. Okay. Although most near-Earth asteroid orbits are reasonably stable, over the time span of a few centuries, eventually they will end up either being ejected from the solar system or hitting one of the terrestrial planets. Within a time span of a few centuries. It's estimated that eventually 25% of the population of near-Earth asteroids will eventually impact the Earth. Ideally, if such an asteroid were discovered on a collision course with Earth, we would like to be able to do something about it. The two most promising strategies would be to hit the asteroid with some sort of an impactor in order to change its orbit, or alternately to change its trajectory with the detonation of a nuclear weapon. Using either approach, it's important to understand the internal structure of the asteroid. The softer and more easily deformed an asteroid is, the more difficult it will be to deflect it without shattering it. There is some money available for this type of research, but it's probably not a real pressing concern, being as we haven't been hit with that type of an object for 65 million years. On average, they anticipate that the Earth should be hit have a major impact every 30 million years, but it's been 65 million years now. And of course, the fact that it's been a long time doesn't affect the odds of us having a having one soon. Eventually it'll happen, but it may not happen for millions of years. Okay. So that brings us up to the asteroid Apophis, which was either named after a character in a science fiction TV show or an ancient deity. In either case, Apophis loosely translates as pure evil. Apophis is too small for an impact to be considered an extermination level event, but it's big enough to cause widespread damage. A Pacific Ocean impact would cause a gigantic tsunami which would sweep across much of the continental U.S. In 2004, when Apophis was discovered, early orbital calculations gave it a 2.7 chance of impacting Earth at closest approach in 2029. And as the orbital calculations improved, it was realized that Apophis is going to miss us in 2029 by 31,300 kilometers. This is within the radius of geostationary satellites at 42,000 kilometers. The flyby will be close enough that the orbit of Apophis will be significantly changed by Earth's gravity, and there is still some possibility of an impact at a later close event. The reason that Apophis has a chance of hitting us is that where the orbit of Apophis intersects the orbit of Earth is at what's called the rising node in the orbit, or the ascending node in the orbit of Apophis, which is where it crosses the plane of Earth's orbit. And so the two objects are going to be, well, if both objects were at the ascending node at the same time, then a collision would be highly probable. 2029 is going to be close. When it goes to the new orbit, it'll still be passing through that same point. That same point is going to be common to both orbits. So it's possible that sometime in the future that such a collision might occur. I think they've calculated out now that it's not going to happen for several, I don't know how long. They've calculated out that it's not going to happen for the next 3 or 4 orbits, which is about, each orbit is about 8 years. Well, yeah, each orbit is about 8 years. So that's its orbit relative to Earth. The close flybys are going to be once every 8 years or so. And they figured out that it's, for the first 3 or 4 of them, it's not going to hit. So we're safe for the time being, at least. Okay, here we go. Astronomers are pretty sure we'll be okay with the 2036 close encounter, and the next one will be about 2044, at which time I will be 90 years old, and if I'm still alive and I get taken out by an asteroid, I guess I'm okay with that. Yeah, I can rest assured I'll probably die from other causes before that happens. The rest of you probably will not share my good fortune and that I will die before that happens. But of course, there's always killer aliens to worry about. There's a good question. Are killer aliens more likely to take us out than an asteroid impact? I'll let you guys worry about that. So this is a picture of Tutatis. It's a 5-kilometer long near-Earth object that approached within 3 million kilometers of Earth in 1992. And it's a reconstruction of its size and shape obtained by bouncing radar waves off the asteroid during its flyby. Tutatis appears to consist of 2 irregularly lumpy bodies rotating in contact with each other. And if I remember correctly, I think we had like 20 minutes warning of the Tutatis near flyby. And that concludes the video lecture for section 13.2.